Okay, welcome everyone. Welcome people on live stream and in the Zoom meeting to the Keshe Plasma Reactor group for Tuesday, June 14th, 2016. And as is our custom here in Keshe Plasma Reactor group, we have Lee Coates to start things off. I see, Lee, you finally got that thing to light up. It's just glowing away there, it seems. Can you tell us what's happening with your nifty device of the week here? Not hearing you. I'll unmute, or whoops, unmute you. There we go.
This week I did an Infinity Quantum 6 reactor, like NASA's favorite beast. It's got the quad cores in battery capacitors, so it supposedly has 138 field interactions for the plasma energy going through it. And first one of these I've made. I just got finished today, so it's really still drying out a little bit. But
so, what's the idea? You say it's got four main coil sets. Is that the way it works?
No, each battery plasma each battery capacitor, it's not a solid core wire to it. It got an infinity loop in the middle of the capacitor.
Mm-hmm.
So this one's got like three bends, or in other words, four wires, and then you twist them together to make the infinity loops.
Okay.
And the idea is to get more field plasma interactions, field interactions.
Okay. Well, it sounds like a lot of interactions going on there.
Yeah.
So have you plugged? Oh, you just finished it, so you wouldn't have plugged it in yet or anything, I guess.
Yeah, it's plugged in right now. That's what this light is.
Oh, I see. Okay.
Lighten that up. So the idea of Mike's on about this AI that can come in through our plasma reactors and interact with us. I know Keshe talked about it, but Mike claims that they can get in through the Keshe reactors too. So by putting multiple wire strips and twisting them up, and it's a random twist, just however your electric drill twists them and how you want to hold it, that provides security, so people can't break, so this AI or other people out in the plasma can't break in through your reactor and talk to you, I guess, or affect you.
That prevents that from happening? Is that what you're saying with the?
That's Mike's theory. Yep.
I see.
That's what he's telling. So.
Okay. Well, it seems like a handy thing to know. I hate it when those evil entities enter into me and so on. But yeah.
Yeah. So anyway, yeah, that's. I think I'd prefer to. These ones are just as easy to build as the Q6s that Keshe has, but I think these offer a bit better security and stuff. So I think right now this is my reactor of choice for building, but that can change.
Right on. So what do you expect to get out of this in the next while, let's say, if anything? Do you have any expectations?
This is a power reactor. We still got one of my reactors downstairs that's got clockwise coils on it and stuff. I might replace that one, or I'm thinking maybe I'll build four of these and put them in a Starship formation, see what happens. I gave two of my Q6s to my mom and dad, but my mom and dad are all religious, and when I showed them how you could talk to your coils or whatever, they got worried about like devil was going to get back to them and stuff. So
yeah.
Probably got to give them two of these.
Probably that something you want to leave out of those family conversations.
So, they don't know too much about the plasma and stuff there, so they get. swayed by this devil stuff. My brother-in-law's a pastor, and he's a extra. He can take the devil out of people and stuff. So there.
Well, it's a concern that many people do have, and it's something that needs to be addressed in some way or another. If we can continue to look at the topic as scientifically as we can, that's probably an advantage. But it's a difficult topic, and it has been for the last several millennia.
Yeah.
That's
So,
why.
I had a few questions on this. Number one, just these plasma interactions with the wires going back and forth or whatever. I don't really recall Dr. Keshe talking too much about plasma interactions in that way and whether they're good or bad or whatever. Any comments?
What do you mean plasma interactions in which way? With
Well,
between the you talking about between the wires
okay.
or
Let me back up a bit then. In the plasma capacitor, the energy comes in one wire, goes through the capacitor, turns around, goes back through the other way. So one way it's going through magnetical, and it turns around, it's going back gravitational, and turns around going magnetical and goes back gravitational and out on this quad one.
mm-hmm.
So that's what I mean by plasma interactions. The going back and forth and switching from sort of gravitational to magnetical.
Yeah, I'm not sure. Keshe was never a fan of twisting all the wires together. He was pretty much against that it would cut the plasmatic field into many pieces, basically, rather than one continuous unit. So, but Mike is of a different, and many others are of a different bent that way in terms of, creating the bends deliberately to as a way to direct the plasma, I guess, and so and perhaps even multiply it. So, how do you see that? How do you see the twisting working into the equation?
Well, right now you can see my it turns red about 3-4 inches away. Mike had one of these in his workshop where he was getting it turning red 6 feet away. So it looked like it was a pretty powerful device that he had, but I don't know how he might have had it loaded up with 1500 watts or something
Mm-hmm.
in order to get that kind of interaction.
Mm-hmm.
If that seems to affect the field strength for the magnetic fields that we're detecting with those little detectors. Right now, I got nothing on it, so I don't even have the light turned on. So, but so that's.
Okay. Well, thank you for the.
So we don't really have. Well, I guess there is some coils wrapped around these capacitors, but really the fields are going back and forth through that core wire, and I'm thinking probably the magnetic field that I'm detecting coming off there must be coming from the core wire. I'm not sure whether it's coming off these other wires, the little coils around it or not. But excuse me.
There's sometimes a coil will contain the field within it, and so the field doesn't get outside the coil, basically. And there's different ways of looking at that, I guess. Plasmatic.
Yeah. And Mike thinks that if we get 360 of these built, that'll form a whole dome around the whole Earth and protect the Earth from whoever wants to get in. So whether that's true or not, we'll find out, I guess, if we ever get that many built.
I think
another comment Mike was making was that the wire size on these things doesn't matter whatsoever. So like this unit here, he recommended using 18 gauge wire. So that's what I used here. And it's, it's used for a house power unit. So, but from what Mr. Keshe has been telling us, you'd normally go 14 gauge wire for a house power unit. So I just wondered what people's comments were for when they say wire size doesn't matter for plasma flow. because
Yeah, if
my
it works purely on, if
the
it
larger
works,
the diameter wire, the more circumference of nano-coated material you got there for the plasma to flow through. So I would think that larger wire you can get more plasma flowing through it, but maybe it's being such a superconductor, maybe it doesn't matter. I don't know.
right, that's probably true. And it might be a case of if it's not working as a superconductor and it's working on the matter level, then if you have 18 gauge, it could melt, where 14 gauge could transfer the amperage on the matter level without melting the wire. So that's one aspect. If you plug
Rick,
in. Hello?
ask you a question.
Sure.
Um,
Who's that?
you know,
Sorry, Zane.
my name is Zane.
Okay. Hi.
Zane Lott. Hi. I've been making my GANs, and I've been observing them as much as I can, because I really want to understand them. And last week, beginning of last week, I started a batch, and they were going pretty good. And then I added some hydrogen peroxide, 90%, the food grade stuff. Well, it's food grade 35%, but it's actually like 90% hydrogen peroxide. And it seemed to turn all the GANs into like fat. And I got I can show you something in just a minute. Let me stir this up and then let it settle a little bit.
Okay, just a second, Zane. Lee, are you pretty much done there with your demo for today, or do you have more you wanted to present there?
I got another topic for later, but I was just wondering if there's any questions or comments on my unit. I'm pretty well finished.
All right, then we can.
Hey, brother, I'm building one of those myself right now, and I don't know how to wire it up. I've had it unfinished for about 3 weeks now, and it's kind of disturbing me.
Okay, he's got some new videos out on his YouTube channel, Mike Nashif. Search Mike Nashif, and that's the name of his YouTube channel. They just came out about a week ago, and he goes into detail on how to wire this thing up again.
Okay.
Okay, thanks, Lee. That's good info. Anybody else with any questions for Lee? I have to check the live stream. I don't have that open here, so let me just get into that.
Hi, everybody. This is Mark from Detroit.
Hi, Mark. How you doing?
Good. I have a question for Lee.
Okay.
Shoot.
Hi, Lee. I watched you forever and a day, and we, with your nano coating and everything. I had one question for you. When you made your big batches of nano coating and your plates for your gans.
Yep.
When did you wash them, and how many times did you wash them in between taking them out of your 5 and putting them, like to make the plates for nano coating? I understand now that you should wash them every time because of the caustic. You don't want to keep the caustic on the plates, or I'm using pipes, but whatever.
Okay. My plates are made out of copper pipe, which
Yes, you cut them and beat them, and I did. Yes, I did the same thing. I'm changing my system because I wanted a little bit more room now, and I didn't want to cut them, and it was a lot of work. But anyway, I just was wondering the washing part of the nano coating.
Yeah, so I got a big 5-gallon bucket that I nano coat in. They start off in the bottom layer and get in the liquid in the bottom.
Yes.
And then they go up in a series of racks as they each time and get steamed.
Yes.
And then as soon as they come out of the top of the bucket, I go and just rinse them real good under the tap and then let them dry.
Oh, once you just steam them and let them steam in your little cooker like you had, and the caustic was on the plates for 24 hours. Then you took them out and washed them under tap water.
No, I just like my bucket's set up that they start off in the liquid and then they get steamed on the first rack above.
Yes.
And then they get steamed a second time, a third time, and a fourth time.
Yes.
And then the next time they're out the top of the bucket, and then I wash them. I wash them right at the end.
Oh, at the very end.
Yeah.
Oh, okay. I'm washing them every time.
That shouldn't hurt, I don't think.
I don't know. I'm trying a different process this time, and I'm totally out in, because you know how Keshe says, try different things. And I've tried, I watched you right from the very beginning. I took the copper and cut it in half and pounded it and steamed it and stacked it and steamed it and, bathed it in the caustic. This time I tried a different, I'm trying a whole different direction, you might say. So what I don't know, I have some pictures on my Facebook where I bought a big roasting pan that will take the water, the temperature of, it's a big pan. Here, let me put, I don't like to talk without being able to be people seeing what I'm saying. I use my hands a lot. Hi, everybody. So I bought a roasting pan at the flea market. It's a big roasting pan. It'll take the temperature up. The knob says 500, but now that I'm dipping it in there with the caustic in the pan, it only takes the water up to boiling point, which is about 200 degrees. So I took I'm starting right from the beginning. So I'm trying to build nano coats. So I don't know if I'm doing it right or not, but it looks absolutely beautiful, and I'm just asking for suggestions, or maybe I'm doing it wrong, or maybe you can tell me if I'm doing it right. But I right off the bat, I want to tell everybody, when you heat that pure lye with water in that roasting pan, there's fumes that are coming up, so you don't want to breathe that at all. So I wear a gas mask, C3, organic gas mask. So at least I'm helping myself a little, keep myself covered with my gloves and everything. And it's hot. These pipes are hot now. When I'm coming out of the water, it's 200 degrees, and I'm dipping it in ice cold water that I've been keeping in my refrigerator. And I've been doing this now I've done it, the process now, for at least 5 times. This is the 5th time, tonight's the 5th time. And each time I keep looking in the pure water that I'm dipping it in, from hot to cold, caustic. It's all pure caustic in filtered water with just pure lye in the water, and it heats up. I put the pipes in. I got it all laid out real nice, and it's absolutely cold when I start, and I turn the thing on, and I let it cook up for about 2 hours, and it just cooks and it boils. And then at the boiling point, I say, well, how much more can you get out of it? So that I shut it off, and I have my gloves on. It's hotter than I can't put my hand in there, grab one, put it in the cold water as fast as I can. The water was in my refrigerator, so I know the water temperature is like 38 degrees, 34 degrees when I start. So I'm trying to keep a log of everything that I'm doing, and I'm just saying the nano coating is just really pretty. And if John's on the line, I know he nano coats by putting in caustic in a bag, and I'm just asking John now with a little tech support what he thinks about my process. If I've explained it to where he can kind of comprehend it, or Rick, or anybody that can kind of comment on what I'm doing.
Well, what's the thinking behind dunking it in the cold water?
That's a question I ask myself. I don't even know, but I learned back like I told you last week, Keshe told us to go from hot to cold real fast. So I don't know. And
that was an old explanation of a fire process.
Yes. And I'm just trying to take processes from that, because he didn't say that just because for no reason.
Well, there's lots and lots of people that are mixing these things up together and they're not getting anything out of it. I'm not saying don't mix it. I'm just saying think about what you're doing. Why would you want to do that? Why would you want to freeze that in that state? Looking at it from a metallurgical point of view, when you heat up a piece of metal, you shift all of the molecular or the atomic structure of the metal. It relaxes and it all homogenizes, becomes a nice, smooth, even.
When it's hot.
Well, when it's hot, yes.
Yes. Okay.
I'm thinking particularly like when you're hardening steel. Okay, when you bring the steel up to 1380 degrees, the carbon melts, works its way all through the atomic structure, and then you freeze it, either in oil, water, or air, depending upon the kind of steel you have, and it locks that carbon into place. Now, I would imagine a very similar thing happening with what you're doing when you have the high heat, the atomic structure, the popcorn that we're making on the surface of the material is going to be nice and loose and fluffy and floating around and just barely hanging on. But when you freeze it, you're going to lock it. Now, I can't say whether that's a good thing or a bad thing. I don't know. But from what I understand about what we're doing with the nano coating, we want as loose a structure as we can get. We want the largest, puffiest popcorn we can have. So freezing may be detrimental to what you're after. I mean, a slightly smaller structure is going to have a slightly limited bandwidth in the plasma. Okay, it's a finer filter, for lack of a better example. Now, with an energy system, probably won't matter. With a health system, you're going to want as broad a bandwidth as you can get. This is why fire coating doesn't seem to work very well for health systems, because the fire coating is a very fine, very small structure, very fine filter. Whereas the caustic coating, when you look at it under the electron microscope, it's a very coarse. It's like the difference between 400 grit and 40 grit sandpaper.
Mm-hmm. So I'm making 40 grit?
No, you're making 400. Well, no, you're probably making about a 240, because you're starting off with a really coarse structure, and then you're freezing it, you're contracting it really fast, really hard. So you're locking, if there's any stresses, again, I got to look at this from a matter state metallurgical point of view.
That's what I'm trying to do.
When you freeze it, you're going to lock any stress that you put into that structure into place.
Where would the stress be, though? You know, because
the stress would be within the interaction between the individual atomic fields. If they're not evenly spaced, evenly configured, when you freeze it and they lock into place, there's going to be some of them in there that aren't quite in the right spot. If they can relax gently, cool off slowly, they can shift and adjust and move a little bit. Now, again, I'm probably not looking at this from the right point of view, but that's what's coming into my head when I think about the problem.
That's why.
Yep, exactly. And this is why I asked. This is why I asked why was, what your thinking is. If you're doing it for a specific purpose, then yeah, there's probably is a very specific purpose to do.
Well, like I said, I'm not trying to create. I'm just doing what I feel is right. Okay,
So that's fine. That's fine.
You know what I'm saying? We're all supposed to create stuff. We're not supposed to. We're supposed to be outside the box. We're not. Everything we do is not wrong. So my thinking on this was, if I stop the cooking process quickly, like you said, everything that is happening will freeze at that process. So each time I do it several times, like Rick said, it'll be imperfect, but there'll be channels probably for it to energy to flow through, because boom, it stopped. Boom, it stopped. I don't know. I'm just,
yeah, that's
yes, yes, yes. Wouldn't that tell us that copper is made in layers then? Because
well, what I'm thinking when I was looking at that the first time, what came to my mind was there's a difference in the thermal expansion coefficient between the nanomaterials and the elemental copper. And if you have two materials, dissimilar materials with different thermal coefficient properties, and you adjust their temperatures over a drastic period, or a drastic temperature change over a short period, they're going to delaminate. They can't stay together. This is how the bimetal strip in your thermostat works. But they have very close thermal expansion properties in two strips of metal, one side by side. One heats up and expands a little bit more than the other, so the spring straightens out a little bit, or curls up a little bit, depending upon which side it's on. And I have a strong feeling this is what's happening with the fire method. When you're heating and cooling with the fire method, is the copper is cooling too fast, and it's pulling itself away from the nano coating.
I almost had that happen when I was just caustic coating, because it was so uneven that it seemed like it was drying, or either it was uneven. But this way that I'm doing it now, each time I look at it, it's completely even. And I would be, I have my stuff out in my garage, but I could run out there and go show you a couple. But like when you showed that you when you put the little pieces in the bag and you put a caustic in it for a little while, how nice and black and even it is.
Mm-hmm.
These look the same way to me. Whereas
are they a shiny black?
No, they're a dull black.
Okay, because the best coating that I've created, I've only done it a couple of times, and I don't know exactly why it happened. But when I look at the piece, I put the gloves on and I pick it up and I hold it in my hand. It looks like a hole in reality. There's no shine. There's no reflection. It doesn't reflect any energy. It looks like I'm holding a hole. And that's the kind of coating that I'm looking for, because I want it to absorb as much energy as possible. Again, that would be for a specific purpose. You wouldn't use that kind of coating for all applications.
Well, no, this is just my beginning application. This is the base. I'm at a base point, and this is the starting point for me. I got rid of all my stuff, and the way that this looks now to me, because I could just kind of tell you my step by step now, because I've been doing it for the last 5 days. Is I heat this up to the temperature. I dip it in the water, the ice cold water. I put it in the cooler, and then I have a cooler that has wires, and I use my meter to discharge everything. But I have it so that everything lays on top, and I have a discharge on the bottom, so that I know that everything's going from top to bottom. And then once I do that, I let it discharge I'm done at 11, so I let it discharge from 11 till 6 in the morning for about 5.5 hours, 6 hours. And then I take the top off the cooler, and I set it outside in the sunlight to let the nano coating dry and absorb the sunlight. And then when I bring it back in the house after the 8 hours of drying, when I get back home, I bring it back in and I discharge again. It won't discharge anymore. It stays at about, well, when you put my electric meter on 200 millivolts, it stays at about 48 to 50.1, 48, 50.2. You know, it stays in that range. It won't go down and won't go up. It's not negative anymore. It just stays right there. I don't know what that means either. I can take pictures right now, and it's still sitting right now from today at about 48, 49.
Okay, well, I guess we're gonna find out in how it does GANs and how long it lasts in your solution. Because that was the big issue that a lot of people were having was if you didn't get a really robust coating and you didn't get it with the parameters just right, the coating just came off. It only lasted a couple of days and then you're down to copper and it doesn't work anymore. So
Right.
I guess it's over the next 2-3 weeks, we'll find out how your coating does in actual practice.
Thank you, John.
Just a comment. You know, a year ago we were doing this discharge stuff with the voltmeter, and then it got changed to where now we're using the voltage in the ohm setting to align our nano coatings. We're not discharging them anymore. At least that's my understanding. That's what I'm doing. So
I have no idea where that came from.
which
Adding voltage to it. When you put the meter on and you discharge, you pull the ions out. What I see occurring within the structure is the individual ions are being dragged through the magnetic gravitational fields, and they create a tunnel through your nano coating, which creates a plasmatic conduit within the coating and allows the plasma to flow through that conduit. Adding electricity, you're just adding ions. You're gonna create more ionization within your system, which is going to be a more random mag-grav field interaction within the structure of that coating.
well, the idea was you're when you make your coils, you're supposed to have a positive negative end on your coil, and then when you run the power through it, you got to hook it up the right direction to get the flow through the coil and align it in that direction.
Yes, but you're not adding electricity. The coils already have a polarity, and you have a specific.
Just by training them, you're not getting aligning them in the direction.
The electrons are going to go from the negative side to the positive side because they're negatively charged, so they're going to be attracted to the positive end. The whole point of doing the coils was to create a longitudinal path through the coil, through the structure of that nano coating along the length of that coil, to give the plasma the idea of where you want it to go.
So you're saying we got to measure the bare copper wire, find out what the positive end is, then coil coils, and then nano coat them, and then when you drain them, it automatically flows in the right direction because you've set the direction, or you've found out what the natural direction is at the start.
No.
The way I'm doing it is I'm giving it a positive negative. I twist one end of the wire over, and then after it comes out of each seaming, I the red lead goes to the twisted end, the other black lead goes to the other end. So it's always always got the ions or whatever, the electrons flowing in that same direction.
It's kind of what's going on right now with all of that is kind of like trying to build a house with a gardening book. The coils have a direction. Okay, you've got a magnetical side, you've got a gravitational, or a magnetical end, you've got a gravitational end. The gravitational end is the input, the magnetical end is the output. This is why they use positive and negative. The negative is your input, that's where it comes from. The positive is the output, that's where it goes. And when you put the meter on it, because the meter is polarized, most meters have a protection diode in there that won't allow reverse current. Some of the newer ones you can run a reverse bias on them and it doesn't really matter, but they work better in the positive bias. So you put your meter on there, and if you put your meter on the correct way with a voltmeter setting, so you're not adding energy to the system, whatever ionization is in there, whatever charge is in those coils is going to flow into the meter and make that pathway through your system. If you put your voltmeter on the ohm scale, which is 1.5 volts usually, you're going to be adding ionization to your coils, which in my mind actually is going to interrupt that plasma flow, because it's going to create a much more of a random pattern within the nanostructure.
Yeah.
Yeah, the whole point of putting a meter on there is to drain the ionization out of the nano coating.
Yeah, I also believe is it not aligning, the nano layers?
To some extent, yes.
I mean, I see it as two different processes. When you're draining the nano layers, when you're nano coating, that's what you're doing. You're doing a different process when you're actually aligning the coils, putting the meter on it. It may be using the same process, but they're for different reasons, is my understanding.
You got to keep in mind that the ancients did this and they didn't have voltmeters.
Yeah, well, true enough. But yeah, I just see it as an alignment process. And as you say, the polarity on the coils through the plans, it's not electrical. It's a way of determining direction. You can just as easily do it with in and out.
Yeah, that's exactly what
about it. Yeah.
That's exactly what that polarity is. It's in and out. It's not positive, negative like the ends of a battery.
Yeah, exactly. In electronics, when you deal with coils, they use a spot to identify which is the inside, the incoming, outgoing, that sort of thing. It's the same thing. It's just using plus and neg, and a lot of people confuse that with it actually being about power, but it's not. It's yeah.
Yeah, there's been a couple of things that came out in the teachings that wound up confusing people that way. And it was actually explained why in the teachings, but a lot of people missed it. And that's all it was for, is it's one's in, one's out. You don't have to get any more complicated than that.
Yeah, definitely.
Excuse me, Rick, do you know you're not recording on Zoom?
Oh, I forgot to remind him.
Yeah.
Well, we got the live stream. That's better.
Okay. Sorry.
Okay, what else have we got here to show and tell today?
Well, you got a unit running. I got a unit running. I can actually hold my hand about 2 inches above the top of my maggrav unit. I can feel the fields. It feels like how do I describe it? It's like a pulsing feather. It's the strangest feeling I've ever felt in my life, but it's there. I can actually perceive it with my fingers.
Yeah.
Does it feel like it was when you put the spirals in your shoes?
No.
More or less?
Totally different. Completely
Okay.
different feeling.
Better or worse?
Is an orange better than an apple? It's just different.
Don't start that fight.
Let's take a look at
And
it.
then the banana people get involved. Oh, jeez, what a mess! Fruit salad all over the place. Yeah, that's right. Well, that's a good comparison, though.
Well,
Which is better?
how do you describe it? I mean, you can't. It's not. There is no better. There's just different. And I don't know. I can't even put it into words. Some of my experiments that I'm doing right now with the health pens and gans, I want to see if I can get the health pens to actually manipulate the gans in a little jar of water. and it doesn't seem to be working. I've got a little jar of GAN sitting on top of my MagGrav unit, and it seems to be trying to climb up the sides of the jar a little bit, but I'm not seeing the extreme reaction that I would have expected.
I was going to ask you, John, what sort of what are you expecting? What are you aiming for?
Actual articulable motion within the GANs that I can set my video camera on and film.
Yeah, I've had a hard time getting the GANs to dance as well. But you know, I've discovered what might be a secret in the last couple of weeks here, and let me relay that. Let me go grab my secret jar. I'll be right back.
Ooh, secret jars. We like secrets.
Hydrogen peroxide.
I don't know. Maybe my lead GANs is too close to the whole thing, and it's just sucking it all up. I don't know. But I've got a 2-ball reactor on ping pong ball fans running. I got to run it 24/7 because it's actually helping to cool my computer. And but it's just running. I haven't noticed any effect from that. I don't see any spinning lights or visual distortions or anything like that. I've got a health pen with the 3 big ganses sitting around the outside of it, pointed straight up with a little jar of CO2 GAN sitting on top of it. Hoping that I can absorb some of the plasma from the interaction of the big three into the health pen and divert it straight up through the CO2 GANs on top. Doesn't seem to be doing anything. What else have I got going? Well, the MagGrav system is running my computer and my sound system. And when I plugged it in, one thing I noticed, Rick, you might be able to give some insight or at least have a little parallel with this. My monitors, I have 2 monitors. I've got 2 mixers, audio mixers. One's running my microphone, one's running the output sound. And the computer was off when I plugged it in. But the monitors, the mixer, my internet modem was on. The mixers were on. And it was everything came on like a soft start. It wasn't, when the power comes on after the power's out, everything just goes pop and it lights right up. Well, this kind of, it was it took a second and a half for everything to kind of power up when I first plugged it in, which was a very interesting effect. And I haven't unplugged it to see if I could reproduce it. But I wonder if anybody else had noticed something like that.
Yeah, I'm not sure what to say about that. Any other comments about that particular aspect?
I have noticed effects like that. Yeah, it's hard to sort of pin it down, but yeah, I found that my lighting seemed to be softer.
Okay, well, being an audio engineer for many years, one of the things that I used to do, I'm very sensitive when people turn amps on and plug guitars in and stuff. Turn the volume down so you don't have that pop. And that's what I was expecting out of the mixers, because I got a 320 watt per side mixer running through a pair of Altex, and then when it pops, it's loud in here. Mm-hmm. And I forgot to turn the volumes down when I plugged it in, and I realized, wait a minute, there was no pop. This was a really nice soft start, which surprised me. I was not expecting that at all.
Have you done any voltage checks on your line voltages?
Well, I tested the line voltage. I'm at about 119 volts here, typically. But this house is built in like the 30s. It's really old. I don't even have a ground in the living room, so my MagGrav is not grounded.
Yeah, it'd be fun to do voltage checks right at the MagGrav, like the in and out of the MagGrav, and see when things start up. Is there a voltage drop, or is there a voltage increase maybe from the a surge from the plasma? Who knows?
Could be the sort of smoothing it a bit too.
I don't have a spot on my power bar, but the little neon light, I've got a Noma High Pro, one of the big yellow power bars with the breaker on it, and a little neon light.
Right.
Neon lights, it's lighting up, it's flickering a little bit as you would expect, but it's running normally, so the voltage is up there.
Yep.
I can't say exactly it's 120 volts, but it's over 90 volts, because those neon lights don't light up below 90 volts.
Right. Yep. Interesting. Well.
Yeah, I had a neon hooked up to my system for quite a while, and it seemed like the neon was very, very sort of soft and fuzzy compared to just how they normally are. I mean, I use them all the time, so I know what they look like.
Okay.
I've taken it out more recently because I thought it might have been interfering, but yeah, that there is something there.
Yeah. Another thing, my computer does run really cool. It's running at 77 degrees right now, and it's about 72 in the house. So this is a big monster 8-core, lots of memory, massive monster system. It should run hot, but it doesn't run hot anymore.
Have you nano coated it inside or something? Or
Well, it's been running for,
have
how long
you
has it been running? Couple of weeks.
It's just it's just being plugged into the mag grab. You think makes it run cooler? Is that the idea?
Well, I was having problems with it overheating. If I was running, 2 of the cores were running at 40%, the temperature climbed and the alarms went off, and it was all kinds of problems.
Mm-hmm.
And now it rarely hits 90 degrees anymore at all. Doesn't matter what I'm doing.
Interesting. That could be a major item if it ends up that computers run cooler off the mag grab. I mean, look how much Apple, Microsoft, and others in these huge server farms are paying for power, and now they're now they're not paying. The people pay them for power now because Apple started their own power system using solar power, and now they power their server farm with their solar system. And I just saw a news item a couple of days ago where they're actually selling power back to the grid now. They have extra power left over from their server farm. So that's interesting.
But the noise on my amplifiers hasn't changed. I still have the background noise on my amplifiers because nothing's grounded, and I have a ground loop between my computer and my mixer. So I've always got that sort of a weird pulsating whine computer noise coming through the speakers, but it's very, very low.
Mm-hmm.
I don't know. I'm half thinking of running a big, long, ugly extension cord. I've got a newer circuit in the kitchen on the far side of the house, which actually has a ground in it.
Mm-hmm.
And I'm seriously thinking running a big, long extension cord and then plugging the system in so I have a decent ground on this.
Won't work though, because then you'll have a ground loop circuit that's created from that extension cord, and it'll act like a giant antenna pulling in every local radio station into your computer.
Yeah.
Let's get back for a minute. You were mentioning putting I guess a health pen or a pain pen inside of gans, a container of gans.
I've got 3 bottles of GANs, the big 3, copper oxide, CH3, and you can't see the CO2, but it's around the back.
Mm-hmm.
With the pen sitting in the focal point of those 3. The little plastic cap on the top is just because the end of my pens are they're pointed.
Oh, that is the pen itself, that whole central column. Is that what you're saying?
That's the wood pen, yeah.
Yeah.
I showed you guys before.
Okay, how did you get it to stand up on its end? Is it pointed?
It's just one end is flat. The one down there with the ball on it, the guts inside were too long, so I couldn't put the little cap on the end. Mm-hmm. But the radius end is the top of this. The radius is inside that white plastic piece.
Okay.
And that's just a bushing. There's nothing inside it. It's straight, clear air through.
Okay.
And then a little tiny bottle of CO2 GAN sitting on top of that.
Mm-hmm.
And I was hoping I'd get a little fountain or something in there, and because that would be really, really cool to see.
Okay, so you're trying to get the little CO2 thing on the top to react to the fields in the pen. Is that or the other ones even? I see.
That's what I was aiming for. And I mean, I've got another bottle of CO2 there. I've got my 2 fan reactors running, sitting over there. And on this side of the house, sitting on top of the MagGrav system, there's another bottle of CH3 GANs. Okay,
well, let me expound a little bit on an idea that I came across this week in regards to that. Okay, so here's the deal. I was playing around with CO2 gans, and I thought, well, what would happen if I took this clear soap? You know, it's soap in a bottle, you know, for your hands, and it happens to be unscented, allergy tested, and hypoallergenic, and so on, because I have sensitive skin. But it's nice, clear, plain, simple soap, non-perfumed, and so on. All right, well, I put some CO2 gans in it, and it ended up looking like this.
Mhm.
And it does not settle out. Over days, it just stays exactly the same. Okay? And let me just show you in comparison. Clear versus cloudy, like CO2 gans when you shake it up. I thought, well, that's interesting. It doesn't seem to settle out. And then I took some water, a liter of distilled water, and I put a few drops of that Gans soap in it, and just gave it a gentle stirring. And this is several days later. The Gans has not settled on the bottom at all, and it seems to be fully dissipated, evenly dissipated, I might add, in this jar. When I first dropped in the soap, it went down sort of as a little cloud, and and then it hit the bottom. Boom! It actually went down pretty fast, hit the bottom, and then it started melting a bit, and it sort of started swirling like a little dust cloud inside there. And then when I stirred it up, it just instantly, well, not instantly, it actually hung out in the bottom for a while. I came back later, and the whole thing was just evenly dissipated and dispersed. And I thought, well, that's quite interesting. And the way I find that interesting is the soap gives one a means of controlling the space between the GANs particles, between each atomic sized, or maybe a few a few chunks or a few molecules of the GANs material. You're shooting for monatomic or monomolecular composition. And generally the GANs is not that way, because if we can see it, then it's not nano, basically. It's already, we see chunks of GANs. Sometimes you see big flakes floating around, unless you shake it up really good at the CO2 GANs. And that's a conglomeration or amalgamate of or not amalgamate, aggregate is the word, of many of the GANs molecules sticking together in clumps. Clumping is what happens. And so it all clumps and goes right down to the bottom normally, which is convenient for many purposes. But what I'm proposing is this is a means of dispersing those possibly monomolecular sized nanoparticles in a more even and complete way, so that each of these particles in here are repelled from each other. They're all maintaining their position from each other. They don't want to all clump together and stick to each other. They want to have their own positioning, you might say. So we can control that positioning by simply the concentration of GANs. If I put twice as much GANs in there, they would be twice as close together as what they are now. I'm thinking, wow, that's pretty cool, because it turns out that in nanotechnology, quite often the gap between these particles is more important than the particles themselves, you might say. So if we can arrange the gap for the exact gap that we need for certain processes, bingo, I think that this would be a way of doing it. Just putting a couple of drops of soap might be enough to disperse the particles in an even way, and then we've got that spacing that we need. And then maybe this can turn into a solar battery, or a supercapacitor, or who knows what, because we have that spacing. No longer do we have the clumping. Now, why I brought this up, why it clicked with me now, is when you mentioned the pen. What if we had this kind of material, rather than it all stuck at the bottom, when we're trying to, what if we stuck the pen inside here? Would we be able to see the fields, positioning themselves from the fields of the pen, the fields of the gans and the fields of the pen? Maybe they would interact more easily, because now all this water is like the plasma of the gans, whereas before it was gans at the bottom and some gans water at the top, but they weren't mixing. They weren't, the energy of the gans was not, the gans water is not the same as the gans itself. This is a mixture of both and evenly dispersed. So I'm thinking that there might be a way.
Gans?
Pardon me?
CO2?
Yeah, this is CO2 gans I use. There's only a few drops of gans in here, and it won't settle out. It's been this way for days, and I suspect it'll stay that way forever, basically.
Do you think it was the amino acids from the soap that makes it dispersed like that?
I'm not sure if it's amino acids or what it would. I mean, soap has it has a dispersing effect. It makes water wetter, as they say, and it can actually
that breaks the surface tension of the water. One end of the soap molecule likes the water molecule. The other end of the soap molecules likes oil. That's the whole point of having soap, is that it'll emulsify any oils that are in there. So I'm kind of thinking that your GANS particles are held in suspension through a similar process.
Through
the end of that molecule stuck to the oil side of the soap molecule.
The fat process, or the amino acid, which is the fat process. Wouldn't that be the amino acid that's in the fat that you put from the soap that was made from the amino acids from the soap, which is a fatty acid? Now you dropped it into that solution, and now they're, like he said, like John said, it's separating like oil and water. They won't stay together. They blast out. So now what you have in that jar is yes, it's all energized. So you could probably, do you think if you put that in another container and put water on top of it and made plasmatic water, do you think water or the plasma would build on top of it, or do you think it would disperse if you added more volume?
That's the thing. I have to do some experiments to find out, like, for example, what is the minimum amount of this soap, this is not pure GANS. This is maybe 5% GANS and the rest is soap. And it's only a couple of drops of that's gone into this to cause the dispersal.
Well, did Mr. Keshe just say that 4 times 400, or we're not multiply the multiplications of the plasma from GANS to plasma makes things exponential?
Yes, exactly. Let me go get a container. Let me try that.
I'm just envisioning a molecule of water, one soap chain with a molecule of the GANS on the other end, and that would make a stable molecular system, which isn't going to want to interact with anything else, and it's just going to remain in suspension.
So it's basically being held up like a hot air balloon would in the air, something like that.
No, not really. It's like trying to take the sugar out of a cake after it's baked.
We're going to find out right now. It's experiment 101 right here.
Welcome to Rick's lab.
Yay!
Yeah, in the moment experiments. I got this beautiful flask today at the dollar store. Actually.
He's got all the cool tools.
I just need one of these would be good. Okay, so what I'll do is I'll take, so I've got distilled water, just a piece of something in there. Bug got in. I already got amino acids in there. This is distilled water. It's probably close to a liter or so. I'll take, let's say maybe a milliliter out of this. It's about a milliliter. Now let me just drop it into this, and I'm not sure if you'll be able to see too much there. Maybe if I change the lighting a little differently, it might help.
That's perfect. That's perfect.
Something like that. And let's just see. I'll just start with a drop, and I'll kind of tell you what happens at the same time. I should have my different little camera set up. I'll just put a drop in and see what happens. Whoops, it's more than a drop.
It looks like it stayed in the drop and fell to the bottom.
See it. Oh, yeah, it starts dissipating immediately when I drop these in.
Yeah.
It does sort of work its way to the bottom, but it's also, okay, there's about a milliliter. Oh, it's staying as kind of little clouds inside the water. You can see the circulation.
Armin, if you're trying to talk, you're really quiet.
Huh?
What was that?
Oh, it just sounded like Armin was trying to talk, and he's really, I could just barely hear him.
Oh, okay. It's far away. How about now?
That's better.
That's good. Hi, Armin.
Hello, guys.
Okay, so I can't see any difference in the water with 1 milliliter. So let me try putting like 5 in and see.
What do you want to do?
Oh, we're just playing. The idea, what the concept, Rick, was to organize the GANs particulates, whether they're molecular, atomic, or whatever size the particles are, evenly throughout the structure of the container of water.
Okay.
Have you done that before, Armin?
No.
So I don't know. I guess you didn't see it earlier, but what I have is this container here. This is GANs in it, and it's like when you shake it up normally with GANs, it looks like this. But this has stayed this way for days. It doesn't settle out. There's no settling.
What kind of water you have?
It's distilled water.
And again.
Pardon me?
And a CO2 gas.
Yeah, CO2 GANs and distilled water. But I've added a little bit of this clear soap.
Oh.
And when I added the GANs to the soap, this is what happened to the soap. It turned white.
Okay.
And I only added a bit of GANs, a few milliliters to this, and it was up to here, and it just turned it white as soon as I started to stir it a little bit. And I thought, well, that's interesting. And it doesn't settle out. And then I added a few drops of this, just about a squirt, maybe 2, into a liter of distilled water here, and it created this. And it won't settle out, even after a couple of days. I thought that's interesting. The GANs is suspended. It's able to stay in there. So let me shoot in 5 milliliters here of this. See what happens. Again, it's very hard to tell.
Have you been using the GANs soap, Rick?
Yes, I have actually.
Have you noticed a difference with it?
I can't really tell. It's just something I use in the bath actually. And yeah, I just give a few squirts into my bath, and with the bath now I also use salt water salt, sea salt, and Epsom salts, and GANs water.
Oh, okay.
and then a squirt of the soap, and I figure I'm good to go for a health bath.
Well, it looks like on camera from here that it's not, it's doing the exact same thing that it's doing in the jar that you made first. It looks cloudy.
Yeah.
Well, it doesn't look too cloudy from here. Maybe it does from your angle or something, but it looks pretty much the same. I'm not looking at big changes, so I'm going to give it another big shot and see what happens here.
Yeah, I would think that with your soap content, it's going to be in suspension as much as the soap will allow, and you might, if you run out of the soap molecules and you've got more GANs than soap, you might wind up with a little bit of precipitate at the bottom.
Yeah, that would be the test, I guess, is to figure out what concentration of soap keeps the GANs in suspension. Sometimes you can see with the laser, but I could see the clouds at the top there for a bit. Definitely there's some sort of layering or it doesn't mix immediately. It doesn't just go in and go poof all out. It hangs around in layers and clouds and so on as it filters through. And it didn't just go to the bottom either. Like normally with GANs, it'll pretty much head to the bottom as soon as it can. But with this, it just hangs out along the top level here and just kind of oozes around a bit.
Yeah, unfortunately, that's not going to help us with if we want to use it for visualizing field flow. Because if it's a homogeneous system, you're just not going to see the flow in it. It's going to be like looking at eddy currents in the water.
One thing that can be done is, yeah, I think that would be hard to see. But what is easy to see is taking this soap. This is the thicker soap. Let me try, I think it's ready to go. Let's see. I'll put a blob in there. Okay, there's one drop. It's making its way to the bottom. Should have taken my stirrer out. And it's making its way, and now just hit the bottom. That's pretty rapidly going down there.
Yeah, that's pretty much what I would expect to see.
And over time, it'll start to sort of melt out at the bottom and dissipate. There's 4 little blobs. They've got little jellyfish in there. Let me see now when I stir it.
Rick, how you created your CO2?
This stuff was actually, I got this from Zyzen, actually.
Wow, it doesn't want to mix very fast, does it?
No, now we have an interesting part where there's threads and different sort of chunks in there, and you can see the currents now quite distinctly. They show how the currents move. So it might be able to be possible to, during that transition period, to stick a pen in or some sort of coil system and see how it was affected before stirring it. And also, I think if we had some sort of lighting, we'd be able, maybe if the, how this looks. Like you can definitely see, definitely see how the laser, you can't see because of all the.
We can.
Yeah, it dissipates the laser quite readily.
Let me get rid of some screens here that are too white. I'll white it out. Show this side here. Yeah, you can see pretty much how it really dissipates the light, actually. And this one, with what we've put in so far, Let me take out this stir stick.
Not as much.
Doesn't seem to be. Well, actually, I can see the beam through there, yes. Normally you can't in distilled water. Definitely can see it. Need to turn some more lights out here to be able to see properly.
Your ppm changed in the water.
Say that again?
Your ppm changed in the water.
Oh, for sure. Certainly.
Yeah, definitely. And this is, like I was mentioning before, this could be a way of controlling and making it even, the ppms, as far as the gans in the water.
How important is the ppms?
Well, as I was just mentioning before, it's important in terms of, if you, for example, if you look at this cross section of particles in this laser beam, I can almost see the particles in a way, and if we were to magnify that, we would be able to see how many particles there were there. And each of these particles are going to have a certain distance between each other, because it's my theory now that after looking at this, that the gans will find its own position. All the gans particles are going to find their own position away from each other as far as possible, but still within the confines of the container. So with this one, we'll have a certain...
which will stay in part.
Yes, right. So
the gans will stay, one near another. The fields will find their position.
Exactly, and due to the fields, there'll be a certain gap between what we call the particle, which is the matter level part of it, or what we see as something visible. But the fields will keep them all orientated and positioned away from each other due to the effect of the soap on the environment. And I think that's interesting, because now that gives us a way to control the gap in the fields between the particles. And we already know that water is like a vacuum environment, basically. So that way, through the ppm, as Armin says, the parts per million, basically we can have a certain, like it might be that a certain angstrom gap or whatever measurement of the certain nanometer gap of the GANs fields, maybe it creates a certain resonating structure, for example, or maybe it creates a certain crystalline structure just because the gaps are a certain gap, and that naturally orientates all these particles into a certain orientation. That raises some possibilities there, I think.
Yeah, if the gans is a big lump at the bottom, it's not really free to move and find its position easily. If it's suspended up in the fluid, then
exactly,
it's like a balloon in the air. It can just spin and twist and do whatever it needs to do.
Yeah, I've been thinking of ways to do that. Like, what about what do you call it? They have ultrasonic sonification bath, it's called. It's made to break up particles, basically. So if you had a sonicator on this,
you need to create mono gas.
Yeah.
Right. Well, that would be the idea.
Meaning if you have a one plate copper, second plate is a copper. One plate zinc, second plate is nano zinc. One plate of gold, second plate is nano gold. So this way you create a mono field, and you have a mono field in a water. Then you can make your mixtures. But you keep your fields mono, then you can create any mixture you want. Understand? Then you can mix all together. Then you can have a composite field. Then you can do the test what effect it gives. If I put, let's say, zinc and hydrogen, and then I put magnesium and lead. Because one is a higher field, one is a lower field if you calculate. Then I mix it together and I have a third field. Then one is empty.
Armin, can I ask a question?
Any position, it will take a different field absorption.
But how do you keep the particles from clumping though? Because if we can see them,
you have a homogeneous field now. You have in a water, it's a homogeneous. It's a field. Don't go to the matter state. Forget about the particles. You have the field in your hand now.
Okay.
You have a field interaction, not the particle interaction. You don't interest in a particle interaction. You see field interaction by magnitude. If you have zinc and you have copper, it's a different. Correct? By mass, it's different.
Mm-hmm. Yeah, but they all tend to go to the bottom normally in distilled water, right?
That doesn't matter.
Well, it is the matter.
Everything goes to the bottom, but the field
technically
is
it is the matter.
No, it's not. It doesn't matter where it goes. The field, you already pass it to the water. You're collecting the field.
Right.
Now you're mixing the field, so it's a homogeneous. Now you have a combination of zinc and copper, or you have a combination of magnesium and copper.
Yeah, what started this whole thing at the beginning, I don't know if you were here or not, was a small experiment that I was doing to see if I could come up with a way to visualize the movement of these fields. And
you don't have to visualize the movement of the fields. They will interact with each other because you have ingredients now. You have a different. It's a lower and higher field and a mixture of it. So it starts the rotation.
Well, how will we know that there's a rotation happening? Just because it's supposed to?
Definitely no. Then you impose, let's say, you will see it.
Well, this is what we were trying to figure out: is how can we see it? Like with water, it's hard to see because there's no, you could have water could be in this going two different directions. You wouldn't necessarily be able to see it without some sort of dyes in there or some way to.
You're looking for a physical interaction that you want to see, the light that you want to see. Interaction creates light. If you have a understanding, because it's a higher and lower. So it creates light.
Okay, well that would be a good indicator then that the counter-rotating fields were doing.
Yeah, how fast you are rotating, what you need from that rotation. You can impose other fields which you can create a matter. What you need. How near you want the fields to interact. That's why your third reactor is in play. It's amazing. Let me go home. I created.
Where are you? You're out and about now, are you?
Arizona.
May I ask a question of you, Armin?
You can ask any question.
What is your process of nano-coating a zinc, a piece of zinc?
I understand. If you understand the process, you don't want to ask this question. Okay, what you have? NaOH.
Yes.
It's a salt.
Mm-hmm.
If you have a salt, even if you put any metal, it's a weaker metal under the salt. Some they react right away. If you put a little moisture, they will create a nano cover on the plate. It's gonna take a time because you bring OH in there. It's a hydrogen. It's an energy. That's why you rapid release. The molecular structure into atomic structure. So just understand, it's OH plays the game. Na, it's a salt.
And the caustic.
There are many salts.
Well, but
what you put in your water, just consider what's in environment in the water, in that box, it's going to be on the nanomaterial. You have to consider that.
I'm trying to.
Aluminium, if I have anything in that environment, what I do nano coating is going to be absorbed by the fields of nano.
So when you say
environment.
Well, when we nano coat each product or each material, so I have two zinc. I have a zinc here that I'm going to make a pure zinc.
I will not mix with anything. I will just nano coat its own zinc with the zinc. To have monofields, you don't add anything else.
You want a pure nano or pure zinc field.
Mhm.
And by doing that, you nanocoat one zinc plate and have a natural zinc plate in the salt solution with a little NO.
Correct. Again, you have a salt, correct?
Yes,
You have a salt.
yes. But I'm asking you, how do you nanocoat the zinc plate to get that process started?
Very simple. You just vapor nanocoat because zinc is corrosive with the caustic, correct? So
Yes.
you put on a vapor, so it will turn black.
And then how many times do you wash that?
What do you mean you wash it? You just put it in a clean water and it's washed.
So when you steam bath it, like you showed on your videos.
You steam bath it, then you put it in a let's say that just understand nanocoating takes time to build the layers.
Well, I'm doing it 5, 6, 7 times, and I'm trying a different way to do it. So I'm just hoping that the nanocoating will build.
No, nanocoating not 1 or 2 times. It's it's enough, more than enough. It's you gotta leave it. 1 time is enough too, because just understand when you could create the condition to release first 2 layers of the material from nano to from molecular to atomic. This process is ongoing because the condition still is in a caustic, NaOH. So until you wash it, it will still grow. Understand when 2 layers are, or two or 3 layers are created, now automatically it pools. You understand? Even it's not in a water, even you're putting in a drying process, so it grows. If you leave it in a caustic, it will come in 100 years, you will see there is no matter left, it's all nano.
In the lye caustic, it'll just continue, metal or not, wood, anything will continue to break down.
Because it will still grow.
Yes.
When you cracked it, if you put a little caustic on it, or caustic environment, still you put a little caustic in a what do you call I forgot, capacitors. So and a sugar too. Why you put sugar?
Well, that's what I did. I put my sugar and a little caustic in my capacitors, like you said, and it constantly creates the rotation.
It's not a point of rotation. It's a CH bond. Sugar is CH bond, correct? You put energy. You release hydrogen in that process because you have a caustic, and the processing is going. Still, in a capacitor, you have caustic, you have sugar, correct? It's still releasing it. You're not seeing it. It's releases. That's everything what you put, you have to consider. Because this is nitrogen, this is oxygen, I have extra, I don't know, carbon in here. So everything in your bucket is a CH bond. Why will you use plastic? Because it's CH bond. We need hydrogen for energy.
So if we're nano coating in glass containers, which I don't recommend because caustic and glass don't get along, it would be a good idea to add extra sugar then.
No,
to increase that CH bond.
You can put a hot glue.
Yeah.
Okay, it's a CH bond. So even the caustic process, cut a little bit hot glue and put it over there. You transfer it.
So let me ask you this, Armin. When you heat it, like the hot glue, when the carbon gets up to that 180 degrees,
it's releases, correct? You don't see it. It's heat. Correct? You make a carbon gas too if you heat it too much, correct?
Yes.
But it's there because you heat it, you release it, you weaken the matter. You create a condition to weaken the matter.
You're opening the matter up.
Right, you're opening the matter up.
And that's what I'm doing. I'm trying to create a nanomaterial by opening the surface by heating a caustic material up to 200 degrees.
You don't need to heat to 200 degrees. It creates, a minute you put hot water on a caustic, it creates more than 200 degrees, if you understand that second. When its reaction goes. It creates
from the steam.
Yeah, from the steam, correct.
Well, I'm cooking mine in a slow process. I'm bringing it up from a normal.
Cooking a soup. Okay.
I'm a cooker. I'm a painter. I'm a cook. I'm slow. And then what I do is once it's up to a high temperature, my nano coating that I'm making, then I shut it down real fast with cold water.
Why?
Yeah, I asked him the same question.
Everybody's got the same question, and this is
A minute you do that, you create the crystal structure.
it's not. I'm just telling Armin this, and I want to reflect it off of him. It's my feelings, and it doesn't really matter. It's
Let's go another state. Let me a little bit different. That you can do it faster, more faster. Understanding how you create gans of CO2 more faster, or Cu more faster. Cu we put the oxygen in the water, correct?
Yes, because I use a bubbler.
Okay. If you use a bubbler, nano-coat your container and nano-coat your whatever bubble.
Yes, all my containers are nano-coated. Yes.
The hole.
Yes, and the hose that I feed the air to is nano-coated.
Okay. So just understand. Now you need to add to the water nitrogen, carbon gas. Make it carbonate water with the salt.
Carbon gas?
When you make a soda, correct?
Yes.
What you do?
Make a gas with the soda. You're right.
Make your gans with club soda. Yeah.
The carbon water, you are looking for, carbon to pass by, you have it in your water.
Yes, exactly.
Carbonizer things now you can buy for about $100, and they have bottles of compressed CO2.
You forget about one more thing. You need oxygen. You reuse it, and sometime it will stop. Then, if you have a CO2, tank, supplying a little CO2 over there, it's always going to create, because you have a field. Now, what I'm going to try to put the field outside, not inside the water. So you have pure CO2, because with the plate, you already create a field, correct? You need the supply. You have the supply, you have the air, you have the carbon. So now you have a field. Now you have to bring to GAN state too. So you have everything you have, you put the
GAN in the box of air.
Like you paste the GANs on the nanomaterial, to absorb the fields, direct to bring the energy. Now you bring the material in the environment, and you create the field to, change it to the GAN state,
Yeah, and you can incorporate more CO2 into your solution as well, just with vinegar and baking soda. Same way you're doing your bubbler.
Yeah, you do.
With vinegar and baking soda.
I bought that, for aquarium. They created that. It's on eBay. Let me post it for you.
Could you repeat that, John? Because I'm ready to
test it, to see how it is. Oh, hold it for a moment. Let me give you.
Sorry, Mark?
Could you just repeat what you just said? Because with my pH meter now that I finally bought, I can kind of control that with the salt and the caustic. Did you say?
No. When you're making GANs, you don't put caustic in the solution. That's for making nanomaterials.
That's who. What is caustic? Same salt.
But if you don't want to use club soda, you can incorporate CO2 solution with vinegar and baking soda. But you don't put it in the solution. You put it in a separate bottle. It bubbles, makes CO2, and you can bubble that into your solution through your bubbler.
Okay. Let me see. Where is it?
Yeah.
You could blow through it. That might be easier. That's CO2 primarily. Then you're putting your own amino acids and cells actually, and plasma energy into it as well, which is interesting.
And the chemtrails that you breathe and dinner last night. And
yes, all of the stuff we off gas.
Better to blow it yourself than to hire someone to blow it for you.
Yeah.
But it's you. You want you in it.
Maybe
in some cases, yeah. In some cases, you don't.
Maybe you want some young, healthy person.
I do, because ultimately, I think all of us have to find a unit that's going to supply us life. And like Mr. Keshe said, these things that we're trying to create should start from home. Home meaning us, that protects us, and it starts right from the beginning. The pH of us, so that we can talk to the material that's going to go into it. We're going to create things, a plasmatic creation that we'll actually be able to interact with. That's my ultimate goal. That's what I want to be able to do. When I started doing this, John, and everything, like I actually, in the beginning, when we first started, I thought, I want to just make a little power and make my family a little bit more free from the grid and all this metering of taking from me. It's
We
way
still
beyond
need that. Listen, we still need that. We still need to do that because it's enough. We're learning where we go.
Yes.
And we're learning from each other.
Yes.
Because we cannot do every experiment.
No.
I love to do every experiment, but we cannot do it. And we show each other that you do different and I do different, and we come each other say, oh, you know what, we did this or we did that or whatever. Here, this is for creating CO2, aquarium plasma, necessarily whatever mixture you do with your baldo, you can supply it, so you don't need to buy a CO2.
Pretty cool. It's only $20 plus $6 shipping here, and
it has all the connections. So you buy
here's the way it works. You have two bottles, one with baking soda and one with citric acid, and you have the gauges and all the caps and stuff that comes with this kit to be able to bubble into your aquarium, which apparently is good for plants and whatnot.
Oh yeah, okay, yeah, that's an even better way to do it. It's a little more control.
You can bring it to your water. Then you have it in a water now. Mix it, first. If you have a carbonate water, that's better. When they make, there are some kind of CO2 pumping into the making soda things. $50 or whatever. They sell in it even with the little CO2 gas tanks, and you just apply it and put the water. Then you have your water already carbonated. Then slowly you just supply an air and a CO2 too in the environment. Slowly,
Yeah.
Cool idea. Thank you.
Air, you always have your, carbon, so you can make a.
Let me,
it looks like Rick, you're doing the same thing I was thinking of this morning, and that was nebulizing CO2 water.
Well, yeah, that's exactly right. I think I found this today at the thrift store, but it's like a humidifier. It's a little mini humidifier.
Yeah,
still got the thrift store sticker on it. But any kind of bottle will fit on. So you could have your gans water in your bottle, stick it on here, and it's got a setting on here so you can crank it up, and when it's cranked up, it actually, you can see the steam coming out of it there now. It's pretty good. So it's a cold vapor. It's not hot at all. It's so it sort of bubbles and blows it out somehow. I'm not sure if it's ultrasonic.
It's ultrasonic.
It can be very good skincare,
Yeah, and also for breathing. People are having good experiences breathing the vapors. That's how the fella got his teeth rejuvenated.
That's what I've been doing for the last few nights is putting some, I got a room vaporizer or humidity thing, and I've been putting the gans in the water tank and putting in the air, trying to help my gans water.
Just the water.
Yeah, just the water. That's all I was using.
If you have mono, just keep it separate. Then you mix it. Then you see what effect it gives it to.
Anyway, I was trying to get rid of this cold here and get the vapor into my lungs.
Yeah, you want to colloidal silver is about the best for that.
No, as copper will do so.
Yep.
Until the 1 drop of copper, put 10 drop of CO2 and 3 drop of let's say 3-4 drop of CH, and use a ratio. Let's say you need the CH, you need a zinc, and you need CO2, and you need copper.
Yep, that's about what I was using.
You need copper, just a drop of the copper, not too much. Just 1 drop is enough.
The interesting thing is I haven't been hungry, so I'm sort of feeding myself as well.
Amino acid in there not to feel the hunger. Because it's a connection.
Armin, Zane here, Zane Lott says he needs to ask you something. Zane, you want to go ahead?
Yeah, hi. Okay. I know you were just discussing adding certain things to your GANs production, certain gases. And last week I experimented with some hydrogen peroxide. My GANs were already going, and I added just enough hydrogen peroxide to start a reaction. And I can't get my video on here. I got some iron GANs, and it looks like it's all protein. And whenever I rinse the GANs, I have a bucket that I've been using for rinsing, and on the top of the bucket is a layer of oil.
Here, I'll show it to you.
So I'm trying to make a universal feeding system that would feed a lot of people. You know, like they don't have to come so close to it. I put some of that the iron in a ping pong ball and got it spinning at a certain speed, and just seeing if I could get an effect. I have a 3-stacker that I'm about to put back together, and I was thinking of putting that on that of the protein of the CO2, the copper, and the iron on the coils, and then ping pong balls for the center, and see how that would work.
Okay, let me show you one thing if I find it.
I can't hear you.
Let me show you one thing. Can I share? Okay. Share the screen. Okay, let's go. Look at this. Can you see the layer?
Yeah, that's showing up nicely.
It's amino acid. I noticed it, you know, I have a pH of 7 and 7.2 or 7.3 in this water. It's not creating much of a CO2, but it's creating a lot of protein. Okay, I measured here. This is my CH3 box. Look at the layer. Because CH3 this is a mesh, because before it was zinc coated, correct? So it starts to create this layer, then it was white before, then it becomes, brown, kind of reddish color, and it's a layer of fat. It's a layer of fat. Look at it, how beautiful it is. So I collect it all. This is lead gans. I used electricity to reduce it.
Did you take a pH reading on any of those besides the one that has the beautiful color?
Actually, this was I was doing some experiments when I set it up this box. I just measured the pH. I have created different boxes. So this one the pH was 7.2, 7.3. You know, I just bring it up. I added caustic, a little bit caustic in here, and a salt water.
And that raised the pH on that?
Yes.
So you're controlling your pH that way?
Yeah. So see, what I noticed that this one start to create a lot, but not CO2 a lot.
Did you use a digital meter?
Yes, I do have digital meter.
Okay, thank you.
So you're saying, Armin, that it was because of the pH that it created so much oils?
That's here. I measuring. I was measuring.
That was the only thing that was different? Like normally, what was your pH before you changed it?
pH 7, so I was measuring that one. 92, this was different box. This was different one. 7, the same box.
And you're saying 7 created the best amino acids?
Yes.
Okay.
This
That
is
makes
different.
sense in a way, because when the acidity of our blood is beyond, what is it, 7.23 or something like that, so it's a very specific range, then we're considered sick or dead if it's just a little ways beyond one way or another.
7.29.
Okay, there you go, 7.29. Then maybe that's what we should be striving for, to get the best amino acid production, same as our body would be.
Mm.
And also the temperature. What about the temperature? Have you discovered anything about that, Armin? Like, should it be at our body temperature to create the most amino acids?
36. Body's temperature is 36.
So that's probably a good temperature to keep a system at that was creating amino acids, especially if it happened to be your own amino acids that you were working with, I suppose.
I'm sorry, Rick, I didn't mean to be a stickler about the pH, but that's why I bought the meter, and that's why I didn't do anything before this, because I think that if you want to create a system that communicates with yourself, you have to have the pH is right.
That does make sense.
And I'm sorry, I started out this way.
This is silver. See, this is pure silver. If you can see it.
Yes.
The nano coating on top.
Yes.
This is the plus, and this is the minus. Look, they both, because you're applying energy, so it's in a caustic. See how they become black? And this was the gans out of it. See the gans? They become light silverish, whitish, silverish gans.
So when you wash that, Armin, how does the top layers that float like that? Are you afraid to lose those?
No, when you're washing, it will come. You leave it, it settles.
Yes.
It's gonna take a little bit. As time to time, just hit the bottle, a few times, and it will bring it down all the particles, and then you just dump the water, whatever caustic water or salt water, and you wash it. Start to washing it. Do the same process again and again, 3-4 times is more than enough with distilled water. And that's it. Keep it in.
Good. Thank you very much.
You're welcome. Yes. That's all.
All right. Thank you, Armin. Okay. Let's see. Lee, did you have something else you wanted to bring up, or did you already bring that up?
I already brought that up. I was going to talk about that vaporizer or the room humidifier.
Okay. Sorry to pre-stage you there. Zane, do you have something you're wanting to show there? I see your video's on. Your audio's off. Let me unmute you so you can talk. Do you want to talk there?
Oh yeah, I just wanted to show y'all. See the
Okay, let me spotlight your video so we can see it. Okay, go ahead.
you see the fat on top of the oh man, phone's messing up. See the fat on top of the water? This is from the whenever I was transferring the water, washing the gans. I have all my nano coating on the outside of my buckets. I just started these yesterday with new salt solution. They're getting kicked off. Right. Can't hear anything.
No, we can hear you.
No, what I'm saying, your connection, you have to keep it. See, your connections are copper. You don't pay
Yes.
attention. If you have zinc, and you have your copper connections, if it attaches the water, you will release the gans of copper too. So consider everything what you do, guys. If you want to create a mono, just in your environment has to be, one metal only.
So do you connect your plates with a copper wire, or sorry, a zinc wire, or would you use copper but above the surface?
But I don't fill up the water up to
Right.
not to touch the copper wire. So you
Right.
just that's the process.
Okay, good, good.
So you can continue.
Maybe it'd be a good opportunity to ask Armin about what assists in rotation. How to maximize rotation, as we were talking about earlier.
Okay. Do you want to respond to that, Armin? Or?
I'm sorry. One more time. I wasn't hearing. I'm sorry. Can you?
Just earlier, we had some people talking about finding difficulty in identifying or getting field rotation with the balls. Is there anything that you can add to sort of that assists and helps in getting that rotation with the balls and fan units?
Fan units. You don't need a fan. You don't need the motor.
Okay, the motor. That's what I mean. Yeah.
What I'm saying, you don't need the motors. That's what I explained. You need the gradients. Today, Mr. Keshe explained it very nicely. Go, thoroughly today's, teaching. Just listen again.
Okay, yeah. Yeah, so I missed that one. I've got to go back and catch up.
You are still thinking in a matter, okay, if I put this gans, that gans, whatever gans, and you calculate what's the ingredients for that gans. One, it has to be weaker, one, it has to be higher.
Yeah.
Then you have the mix of them.
Okay. Yeah. So about getting gradient.
Just go listen to this workshop. It perfectly explains.
Okay. Yeah. I'll catch up on it. Thanks.
If you don't understand, just leave it for a moment. Go back to next day or other day. Go listen other workshop and come back again. You will understand. Don't worry about it.
Yeah.
It was a good workshop, and what I got from it was that if we make our gans and then we go to a plasmatic state, we want the higher states on the outside drawing to the middle, which would be the third part of our maggrav system, which you want to, what I understood was the mixing of the two would be the third part of the middle. Is this correct? Would that be correct, Alman?
Yes.
Thank you.
Yeah, this was in the international workshop, is that correct?
Yes.
Okay, thanks. Yeah.
Fields, not matter. Fields.
I can confirm it's fields. I'm taking care of a pond, and there's some koi in there, and the koi came up like they were gasping for air. I've never taken care of a pond before, and so I made a little spice bottle with CO2, CuO, CH3, and zinc waters, and mixed with more distilled water, and I put that in the pond, and within probably less than half an hour, the koi weren't gasping for air anymore. I was really amazed. And it was just waters. There was no gans in the water, or no visible anyway. I was pretty amazed. So feels as what is that?
Yeah, Pastor, if you understand, if you put, let's say, hydroponics, if they put CO2 water in a hydroponics, you don't need to feed anything else.
Yeah.
You don't need even hydroponics to put it in the water.
Cool.
You can create an environment in a, in your let's say hydroponic space that is CO2 in the environment. We burn gas, correct?
Yeah.
To the plants to feed from the CO2 because they need that. The rest of it they will absorb right away. If you have a CO2, if you have go look pick up a leaf from the tree. It turn upside down. You will see one is shiny, one is like velvety. The bottom side it's a velvety, and the top side it's shiny. Why is shiny? Because when it absorbs the CO or creates the CO2, it right away brings the amino acid on top of the leaf. That's why it's shiny.
Yeah.
Two different nano-coated plates the leaf is made of. In between, it creates the CO2. It's enough to create CO2, absorb the CO2. The rest is coming. It's free.
Well, I got to say,
Oxygen, nitrogen, and hydrogen.
These fish are having so much more better time than they were before I had that. They're swimming, they're playing, it's as if they're renewed koi. So it works.
So just you need, to hang the balls around, your hydroponics that, you have the field interaction now. Now you don't need the gas to burn. You need, the field that it's there for them. Like you bring the field in a box to create the CO2. Now you bring the CO, so now you have a plasmatic condition. Now you bring it into your room. And see how your plant's going to grow.
My plants are growing fantastic in my room. I've just been putting CO2 water into their water. They're all hydroponics. Well, not all, but many of them are. I'm amazed.
Because now you have a field, feed the field.
Yeah.
One thing that I've noticed looking at the agricultural aspect of this, is there a change in the required light levels when you add the CO2 gas?
What levels?
Well, certain plants, say tropical plants, if you're growing them indoors, you're looking at somewhere around about 1,000 watts for every square meter. That's a lousy description or a lousy measurement, I understand, but people understand that. if we add CO2 gans to the system, or CO2 gans water to the system, do we know if that light level requirement drops?
Now you have a field in the environment. Your plant don't need that energy to go search for, for CO2.
Okay.
The environment now, it's absorbed it because it's a nano-material, the leaves, the whole structure. So it absorbs the CO2. Now you brought the same thing, like it's a coils, you brought the gans on top of it, you brought the energy. So the nano material is not looking for absorb the energy from the environment, it's right on top of it.
So that the next layer on that would be to assist the plants in its photosynthesis and creating its sugars. So if we were to add the CH3,
no, you are CH3.
that should take some of the load off of the chlorophyll process.
Correct.
Gonna have to try that.
You have an energy now. Add little bit CH3. You have energy. Transfer the field. CO2 water that you just.
Yeah, John, that'd be a great experiment to see if you can grow tropical plants in lower light levels than normal.
Yeah, don't put anything in the water. No, other ingredients. Just put CO2.
Yeah, I've spent a lot of years teaching kids how to grow hydroponically, and one of the big issues is having sufficient light levels, regardless of what kind of nutrients you have. If we can
again, so you didn't understood that. Your plant is taking whatever it needs from the.
Yeah, if we can reduce or broaden the window of light level, that would go a long ways to help a lot of indoor agriculture.
I know that.
Note that nanoparticles have special properties, and some nanoparticles actually act as light emitters at a certain size. They found that, I think, with the gold nanoparticles and some others as well, possibly some of the ones that we work with. So it may be that, spraying a plant with CO2 gans, or maybe it'll end up being gold gans or something like that, can actually create an interaction with the plasma fields that is similar to the action of light, sunlight or artificial light on a leaf. In other words, instead of coming from a distance of a few feet away for artificial light, or in the case of the sun, 93 million miles away, and it takes 8.5 minutes just for the sun to arrive here, for the light to arrive. Instead, it's being instantly transmitted at a nano level, nano measurement level, from the nano particle, but it's actually the fields, the plasmatic fields of the nano-sized item, call it whatever you like. So maybe there's a way that we can basically spray on sun on our plants and grow them in the dark.
You can grow them in the dark because you don't need to spray. Again, if you hang your balls, it's an interaction which is going to create an environment. Have CO2 interaction. Look, CO2 box, you bring a carbonate water, you bring a carbon in the water. You have oxygen, you can make a CO2. Now you have it in the environment. Now you have a field in the environment. Which your plants will absorb, they need the CO2 to photosynthesize the rest. Amino acid, which is on top of the leaf.
Yes, it would definitely be nice to have a greenhouse where the lighting in the greenhouse is so you can see to get around, and not so that you can keep the plants alive.
Okay, in the nighttime, it's plants are absorbing CO2. Why? In the daytime, they release the oxygen. Because daytime, the sun is there. It's a more of a, a plasmatic field, not the earth field. Nighttime is more of an earth field. That's why they release, they absorb the CO2, and daytime, they keep the carbon, but release the oxygen. The field difference. Nighttime is a field is different than a daytime.
Yeah, it makes perfect sense. Thanks for that.
You're welcome. This is all in the teaching, guys. Slowly go back, listen, parts from there, parts from there. Yeah, it's a little bit easier because I've been in every teaching, so I can remember things backwards, from a year or two of the teachings because I paid attention. So you can do that too. Go back and listen, old teachings, Rick, everything. You've been in every teaching from day one.
Exactly the problem, Armin, is way too much information. Way too much information. And it's hard to keep going back and simplifying. Just keep it simple, and try
keep
not
it
to
simple,
get
not
too
to keep it,
complex.
what we learned, but we remember certain things, then we connect.
Yep.
Then it's easy. So, that's all. Who's gonna do first? Who's gonna fly first? Who cares? The thing is that we brought to the people that we teach freely and everybody understands. We're not hiding anything. They do their experiment, they bring it up. Oh, I did this. Good. Now we know. Let's move on.
Mm-hmm.
Thank you, Armin. That's the way it should be. For many, many years, people have just hidden things that they've found that work, and then they hold it and try to sell it to people.
You cannot hold this in technology.
No, this is free.
It's a joy, and it's to pass it through, and I hope it's for everybody. It's a joy going to be to pass it through.
And so I'm so happy to be part of it. And
you don't carry anything with you, you just gave it.
People that try to profit from this idea will pay dearly.
Can I tell you one thing? Profit is still going to be there until we come to the point that we understand. Everything is understanding. Right now, without profit, you cannot survive. You're not going to keep your family.
Right.
You're not going to make anything. But in your understanding, you understand that your neighbor is the same too. Let him have it too.
Yes. I would give it to my neighbor and everybody freely.
Yeah. Then you bring it to, all totality that everybody do the same. And they enjoy, to create new things. If it's going to be on this planet or in the universe, it's the same. You enjoy where you are. I never feel bad anywhere I go. I'm in Zimbabwe or I'm in United States.
Well, I'm in Detroit, Michigan, so it's kind of tough here. Well,
you're making it. So, sometimes the hard places we live in just make us tougher, basically. As they say, what doesn't kill you makes you stronger. But boy, it's hard in some places to survive. But like Armin says, Armin has a good attitude wherever he goes, and he's been virtually all over the world at this point, traveling through business or personal reasons. And I think that's a big thing, is having that positive attitude wherever you are, and that makes all the difference in the way things turn out. So that's
you just can't lose your sense of humor or that sense of wonderment in the world. That questioning, that part of you that questions, how does this work? I think you lose that.
Dear, what doesn't kill me? I'm strong enough. Thank you very much.
and that makes us better people to help others as well when that situation comes up. So it's all good in the long run. So, okay, anybody else have something for show and tell here tonight? Anyone? Salma, I saw your video was up there briefly. Did you have something you wanted to show? Talk about? Any other questions from anyone? Ron asked in the live stream, how do you nanocoat lead without melting it? And then he says, I guess lye would be the only way to do it.
Yeah, the caustic process is not going to get hot enough to melt lead.
Right. And even melting it may not nanocoat it. It does get nanocoated from, actually lead nanocoats itself quite readily. It's always got, like copper, it always has a oxide coating on it. But it does take on interesting coatings in the case of battery terminals. I've noticed over the years. I've seen so many different colors of substances growing on lead battery terminals of cars that it's ridiculous. And some of them grow literally over the whole top of the battery. So, but that's not the kind of nanocoating that we're interested in. That's actually more of a chemical molecule type process rather than a nano coating as such. So, and also with lead, I suppose you could use electricity for a lead electrode. That'll tend to coat it as well. Lead is a subject I try to keep away from. I've had enough lead in my life, and I try to keep it away from my body instead of being around it. Some people have had bad responses with lead, making lead gans, and every time they walk by it, their hand twitches. One person said, so they put it at the far end of their shop so they don't have to go by it very often.
It's crazy. I've gone to play with the lead a couple of times, and then I'll hear someone's horror story about it, and then I'll put it aside, and yeah, it's sort of oscillating. Now I'm just going to do it. Yeah.
Yeah, it's funny because I have no problems with touching lead, the material substance. I've done that for years. I did it today. I put the battery terminals on the connectors on a battery, and the terminals and the battery connector were both lead. And,
yeah.
I took my gloves off to do it because the gloves were awkward.
Lead capping on roofs and things like that. And I've always had lead around,
Yep, but what was in the headlines of the local newspaper for Victoria, BC today? Lead poisoning in the water in the school systems. That's one of the most disgusting things I've read in a while, where they just recently tested the water systems in all the local schools, and a couple dozen schools had way too much lead in the water supply, even after the flushing process that the custodians are supposed to do to supposedly flush out the lead out of the system. They still have, and it's proven to be cognitive impairments and all kinds of stuff from lead. I mean, even the Romans figured that out a long time ago. That was one of the cause of their fall of their empire. And here we are in this modern day and age, and they don't have regular testing of the water supply for our kids in the capital city of the most expensive province in one of the most expensive countries of the world. This is outrageous. This is just unacceptable to the nth degree. And now they have to sort of try to get it into their budget, and it's a big kerfuffle. And of course, everybody's freaking out about it. They should be. And I just can't understand how. Well, I can. It's because they have cutbacks in their funding, and the school board says, "Oh well, we tested these two older schools and they were okay, so all the rest of them should be okay. They have newer systems." No, well, many of the newer systems were worse than the older systems. So boy, it's a big one, and it just came up last week about the northern communities in Canada having the same issue. One in particular have really high mercury levels in their water supply, and lead, but mostly mercury in this case because of the mill that operated there for years in the 1960s. The government thought it would all go away, and of course it got worse instead, and now they have kids that are deformed and all kinds of problems going on because of that. It's now a mess to clean up.
We have issues here in Australia with house renovating because a lot of the paints they use sort of pre-70s for lead-based paints.
That's right.
So,
yep.
You don't think of that. You're badly going with a stripper and sander and caustics to strip, paint off. And we actually poisoned our cat that was walking through the sandings from the paint and then licking its paws,
Oh, yeah. Wow.
All of a sudden, the cat just keeled over on its side and went into spasms,
Oh, wow. Yeah.
Yeah, so that was a big wake-up call. Yeah.
Yeah, so imagine if we had maybe a GANS paint that we could paint over the lead paint, and it deactivated it. And then when you removed it, your cat could walk in it and it wouldn't be any problem. It would already be bound up to the GANs and no longer free to be able to, be ingested or whatever. It's entirely possible something like that could work.
Yeah.
And again, with the water supply, mercury in the water supply, surely we could have a GANS system of some sort that could act as a filter. We know the GANS goes to the bottom of water wherever it goes. That's where the mercury is in these rivers. It's right down at the bottom in all the cracks and crevices and sludge and so on at the very bottom of the river where the gold hangs out and all the heavy metals. So why not the GANs injected into a river system and have it trickle along at the bottom of the river and picking up the heavy metals and pollution as it goes, and maybe you could retrieve it at the end of the run of the river, and or maybe it wouldn't matter at that point. That maybe it could even be ingested by fish and it wouldn't stay in their organs and so on the way it does now with lead as an ion.
Turn it into a commercial operation, retrieve it, and they can employ people to do that through all the rivers.
Yeah, once that catches on, I mean this is definitely the way of the future. Well, the way I see it is, instead of having military fighting each other, the military will be employed to clean up the environment, and that will be our duty as humans, is to try to make our environment, wherever it is in the universe, better from our passage rather than worse the way it's been traditionally, it seems. Where humans go, you can pretty much smell them, so they leave a trail.
It'd make it a lot more palatable to pay your taxes when so much is going to the military if they were being used for that. Yeah.
Yeah. All right, so we're going to end things fairly soon here. Any last minute stuff that people would like to bring up or demonstrate? Guy, do you have anything there that you wanted to show and tell this time around? Anyone else?
Does it matter what protein you use whenever you're making the feeding system? I mean, do you need a combination of like so many of them, or is iron, copper, and CO2 good enough?
Well, people are using, for example, some feeding systems. People might use a fruit or a vegetable and put it on top of gans water setup or some sort of health cup, and infuse the liquids of the health cup with the fields of the fruit or vegetable, and use it that way rather than just the gans from the three main ganses. Go ahead.
Thank you.
There might be some other feedback on that. There's other ways and means of using the food ganses, depending on how one wants to go, I guess.
Yeah, I tried another method using a blowtorch and ashing it down to just ash, and adding that to the CO2 in my health cup. You know, I've got a thyroid problem, so I used egg yolks, which is supposed to be a good source of natural sulfur, and mango and banana. I just ashed it right down. We'll see how it goes. Yeah.
Yeah, some people say that they don't want to burn the material too much, but I think that there's a couple of schools of thought on that. One is that you can't burn it too much. Basically, you can take it right to the carbon stage, and it will still retain the memory of the fields in the material.
Yeah, that's what I'm sort of working on. Whether that's the case or whether you just lose it all.
Right, and that's the other aspect of whether one might lose the fields and so on. For example, in nano coating, if the copper gets too hot, then you can destroy the nano coating. The copper oxide structure can get actually destroyed. But on the other hand, at a certain temperature, the copper might be red hot, but the nanostructure will stay in place with the copper oxide. It has a higher melting temperature than the copper itself. So,
yeah, well, it's kind of like, well, you know, look what happens in a fire in a forest or something like that. Do you lose all of the minerals, all of the salts, all of the, you know, the whole aspect of it because it's turned into carbon, or, you know, do you retain that, you know, and it just changes form, you know? I don't know.
Right. So how many times can something get burnt and turned into carbon again, and it gets recycled and grows and burns and recycled and grows and burns, and still retain the memory of the original cycle of what happened?
Exactly. It's kind of like the aromatherapy type of thinking of being able to reduce it down until there's no elements of it, the origin left, but the field interaction's still there. Yeah.
Yeah, right. That's kind of the idea I have with this container. I can see that this definitely has the particles in it now from probably maybe 20 milliliters of the substance from this container.
Yeah, you can see how it's changed now. That's amazing. Yeah.
And you can almost see you can actually see the particles inside there. And,
it's evenly distributed.
Yeah,
that's
it is. You can tell with the laser.
Yeah, the laser's much broader now. Yeah.
It's pretty much even all the way up to the top.
Yeah.
Otherwise, normally in gans water, the gans will settle to the bottom, and you'll get it completely clear at the top. You won't be able to see the laser at all. It'll be clear distilled water, which won't reflect the light. And normally you would see a little bit at the bottom where the gans is still floating around a bit, unless it was totally settled out. But this, it starts right at the top, and it's pretty consistent all the way down to the bottom. Interesting.
Yeah, definitely.
So I'm not sure. Well, remains to be seen how that can be used, but I'm pretty sure that is. Whoa. Pretty sure that's quite useful for something.
Well, that was
it's part of it. It's a step, definitely, I think.
Wouldn't that mean that the amino acids are just floating? It's now expanding in the new container?
Well, I don't know about amino acids. If there's much amino acids in here, I maybe you mean the soap itself has amino acids, I guess. Eh?
Yes. Now it's multiplying itself by replicating itself and expanding itself in that new container. You only put maybe 15 or 20 cc's of that in there. Now it's almost like the amino acid that is growing, or just it's expanding in that glass.
Yeah, the way I see it is the actual particles. If there's a particle here and a particle here, then in this stuff, then
Right.
basically they're sort of jammed in together, and there's not a lot of mobility and so on. They're all just next to each other, lined up.
But it's unlocking
They
the
go in,
bonds.
they go into this stuff, which is basically a squirt of this into a liter of water, and it goes to this, and then the particles are able to move apart, and each one takes its position as far apart from the other ones as it can. And the fields, like Armin was mentioning, that the fields are interacting. That Coulomb barrier between each field that's expanded out to fill the container as much as possible, much in the way that a gas will expand to fill the room or container it's in. And the liquid will fill a container too, but normally with the gans, it doesn't expand to fill a container. It just goes to the bottom with the liquids, or as a solid, it would just sit there on the desk. It doesn't expand out into the room unless we have maybe a plasma vapor. But this, as you can see, then we're at the next level where that's expanded out. I'm going to let this sit overnight and just see if it has actually settled out any, because perhaps it will with this viscosity of the soap. That's only a few drops, maybe a drop of soap, or a few drops of soap, basically in there.
Maybe you could put a powered up coil on either side of it and take a reading before and take a reading after and see if it interacts.
What about if you added copper gans to it and started a communication line?
Well, that's right. This opens up a new area to me, because if now the CO2 is all those particles have expanded out to where they are held in place. Now suddenly they're able to communicate with each other because they're not all jammed up and so on. Their fields are open and receiving, you could say. Now, what if you add some of the copper oxide gans into that, which is also probably going to have the same effect with the soap, I expect. It'll be an expansive thing, and then suddenly you've got this electrical network put into your skin network, more or less.
Yeah.
And maybe throw a little CH3 in for energy boost, and perhaps that'll be the three layers all sort of working within each other. The particles would interact and maybe have enough gradient between them to actually cause some rotational effects or some sort of interaction, at least, especially if the particles have exactly the right gap between them and the right proportions. Like, proportions have come up recently as being important. Keshe has mentioned having, and Armin just mentioned, something like 10 parts CO2, 1 or 2 parts copper oxide, and 1 or 2 or 3 or 4 parts of CH3, for example, as one potential sort of mix. So maybe those proportions in a certain dilution factor would bring these particles within the proximity of each other, that they actually start to interact with their fields, and maybe that will create the light between them that we want. just
Yeah.
the random action of movement. And because they're at a certain distance, might be enough to go like zoop, and light flash goes off and zoop, and it's suddenly we have a glass of glowing light. The new drink of the year, the glowing gans drink, you know.
I think that's what we're all looking for as creatures. We're such visual animals, you know. We're looking for something we can see, you know.
Yeah, it's interesting.
You can already see it.
Yeah, so the other thing I want to do is take some of this stuff and put it in a clear sphere and rotate it and see if it forms the gans rings, or is it going to stay mixed up and not separate out like normal.
Well, I think it would be interesting to see if the new solution that you just made gets cloudier, because that'll potentially tell us that it's multiplying in the new solution that you just made.
Mm-hmm. Yeah, well, that's a good point. Yeah, I can look at that.
And that might mean that the amino acid from the soap is helping to feed the GANs and the new solution that you just put it in to now expand itself in the solution so that it becomes as cloudy as what you have in the mason jar.
Mm-hmm, quite possibly. It's maybe it'll make the soap thicker too, even. Maybe this will suddenly become jelly-like or something.
You've come up with a new soap-making solution.
Yeah.
You know,
who knows? In any case, it does seem like a good idea to have the CO2 GANs in soap. I know we're still not into touching the CO2 GANs as such, and we talk about you just using the GANs water. But even that in itself, the GANs water in the soap is a great idea. But I think the GANs in there, I think it's perfect because it does dissipate. You're not getting a big clump of it at once. You're getting a nice, even dispersal. It's of so many parts per million. It's not very much. Like I say, I only put a little bit of GANs actually in here in this larger container of soap. And I think there's something to be investigated with that yet. I can see.
It's one of those things. There's nothing to say that if you just used the CO2 water, but it doesn't have the same field effect. It's just because we want to see something, you know, that it's visual. You can see it separating, you know, that makes it so appealing.
Mm-hmm. Yeah. Well, it's true, and that's why I got this glass today. It's actually sort of it looks like a lab beaker. Maybe it is in effect. Doesn't say Pyrex on it or anything, but it had this neat little stir that came with it too, glass stir. So I couldn't resist, and it was perfect for being able to see through clearly and see also the distance and watch the GANs settle out and so on. So I wanted to do some experiments with that. And of course, the dollar store always gives up something good in those circumstances when you need them. I like this little ionizer thing too.
Code, Rick.
Pardon me?
Yeah,
you need to get a lab coat. A lab coat.
Oh, I do have a lab coat that I wear sometimes. Yeah. Anyway, I think we better wrap things up for today. Some people have to get ready for the private teaching going on in half an hour and so on. So, any last minute questions or comments?
A lot of food for thought. Thank you, Rick.
Good. Thank you, everybody, for participating. It's always fun to hear from people and get all the different ideas, and some of them are quite challenging, and others are just interesting at different levels. So I really appreciate everyone's input. Yep, good one. Okay, thanks a lot.
Thank you.
Always inspiring.
Thanks, Rick.
Okay.
Thanks.
Take care, everybody. I'm going to end the live stream now.